This example is talking about the fastest route. So suppose we want to go from point A to point B, and this is a lake, half a circle kind of shaped lake. So in order to travel from A to B, we have two options. We can go by boat from the water path. We call it L1 with the speed of V1, or we can walk on the land under the route from L2. We call it L2 with the velocity of V2. Okay, so we want to minimize the traveling time, and we know that the speed of walking and the speed of the boat are different with each other. So the decision variable is the theta. So we want to find out what is the optimal value of theta in order to minimize the total traveling time. So the total traveling time is the time on the boat and the time on walk. So here you can see the objective function is defined as the summation of L1 divided by V1 time 1, L2 plus divided by V2 gives you the time 2. Okay, and also we know that the L1 is 2r cosine of theta. So based on this graph, you can easily see that L1 has such a relation between radius of the circle, which is a known quantity for us, and the cosine of theta, which is the decision variable. And L2 is equal to 2r theta. And we already know that the theta is expressed in radian. So this is the Python code for solving the problem. Okay, so here you can see that first of all we have to import the Python Pyomo package. So here you see from pyomo.environment import asterisk everything. And also if we need some functions, we might need numpy. Okay, and this is a description of the problem. So we define a model, we create a model called a model is equal to concrete model, and a small r is the parameter we defined for the model. Model V1 and V2 are also parameters, and also we can initialize them based on the input of the problem. Here we assume that V1 is bigger than V2, and we call it 4 and 3. And theta is the decision variable, and it is changing between some bounds between 0 and half pi, and we can initialize it with pi divided by 3. Okay. And also the objective function is the summation of the time we need for traveling between 2 points. So the expression is 2r cosine of theta divided by model V1 plus 2 times model theta multiplied by r divided by V2. And the sense of the optimization is the minimization. So let's run the first two tabs. So I have run the two tabs, and then I specify the IP opt as the nonlinear solver for us, and the model is solved, and it can give us the required decision variables. So it means that theta is 0. What does it mean? It means that we if we go back to the optimization problem description, it means that we should take the water route in order to travel from A to B. That's the shortest path, and we will travel only 2r. Okay, and that's it for this example. Thank you very much.